Hello guys, welcome back to my channel. And today in this video we will talk about the data visualization. Here I will discuss more than 15 plots with you, and by discussing these plots I want you to master the data visualization. So it's a request to you to subscribe my channel, hit the bell icon, and wait for my some new videos, because I always posted some of the useful videos that actually makes life easy. I'm a data scientist which has been certified in more than 40 certificates, and apart from this, an experienced data scientist. I have also worked as a data scientist. So this channel is all about the data science and AI. So please subscribe it, hit the bell icon, and wait for the amazing content which I will be sharing in the future. So first of all, let's talk about the course. So this course contains 15 different plots, but before that, you must be familiar with these libraries. If not, then you should familiar with these things. I will tell you. If not, then it's also be okay. Uh, first actually the numpy here. The second is the pandas. Numpy is used for the numerical matrices or numerical computation. Pandas is used for the data analysis. Matplotlib is actually used for the data visualization, and seaborn is also used for the data visualization. If you don't know matplotlib and seaborn, after this video you will know these things. Okay, so let's start. So first of all, I will create a variable, and I will here import a csv file. So in that CSV file is actually a toy data set. It's not actually a toy data set. It's a data set which contain the data of man who has a salary, who has an income, and also if they are working in a different city of America. And apart from this, there is also the gender of this man and illness. So this data set is all about predicting the income based on these following features. Okay, so we will actually try our you can say our main agenda with in the on this data set. So let's talk about the first plot, which is called the histogram. Histogram uh, tells you about the distribution of a data, of a numerical data, distribution of a numerical data. For example, I have a numerical data. I want to find out the count of this numerical data, which means that I want to check on which point this numerical data is quite high. For example, I have that income. So let's start with it. First of all, I want to create a field t.figure. It will actually create a figure here, and fixed size must be try to go with 18 by 9. It is used to make a figure. So, and after that you need to do you need to import from the seaborn. You need to import the his plot, and at x-axis I want to pass the income from the df. So if I click here, then you can see it's the histogram. So you can say that when I talk about the 1 lakh, so you can say at 1 lakh we have high ratio, which means that in the data set these are actually the counts with respect to the income. So which means that the people who have more than 1 lakh income are found in this data set, are more found in this data set. Because if I talk about the ratio of the people, then it is around about 3400, which means that 3400 are those people who have salary more than 1 lakh, or it is near to 1 lakh. Okay, you can say 50 1,50,000 are very less, and if you move forward then they are very less, but at this point it's quite high. So what does a histogram do? It tells you about the distribution of a numerical data. So it's actually about the first plot. It was actually about the first plot. I will also mark it down, and I will also give you the code here. Okay, histogram tells you it's the first plot. Now let's move toward the second thing, the second plot. The second plot is actually a bar plot. It is used to compare, it is used to check the distribution between the categorical and numerical variable. So with respect to the numerical or categorical variable, it is used to check the distribution of categorical variable, of categorical variable Actually, forget the definition here. With respect to numerical variables, with respect to numerical variables. So here I will show you what does it mean. What does it mean? That it will tell you what is the distribution of any category with respect to that. For example, I have a column income. I want to check the income with respect to the gender. So for this purpose, what should I do? I will do, first of all, I will create a figure here. Always try to create a figure because it will make your plot very good and wide. So try to go with 18 by 9 as a standard. You can also go with 18 by 10. It depends upon you, but I'm okay with that. After that, you need to import the the bar plot, sns.bar plot, and at x-axis I want the categorical value. What is the categorical value? It's a gender value. Gender is a categorical value. You can also take illness here. You can also take city, but let's go with the city instead of genders. Go with the city because we have more data at city. Why is I want to do the income here? You will have to put the numerical variable. So you can see it tells you the mountain view, the average at the mountain view, the average at the mountain view, average income at the mountain view. And you can see the average income at mountain view is more because the people who have the average income more are living in a mountain view, and there are very the average income of people living in Dallas is you can say is very less. So what does it mean? That in mountain view there is a lot of job opportunities. The people are earning more in mountain view than in Dallas. So it's actually tells you about the distribution, and also tells you that with respect to each category, which category has high average. So this is actually the bar plot, and it was actually our second plot. And you can also add some hui means with respect to the third. And I will go with the hui because it will create a legend here, and with respect to that category it will separate them. So I want to check their illness. Okay, with respect to illness it will differentiate the things. You can see yes have this ratio and no have this ratio. You can also change it to gender. And the one thing is, you can also change the value at x label and y label. I want to check the s label. At x axis I want this city names, and at the y axis what I want to do, plt.y label. I want to check the total income, or average income. And here I want to do plt.title. In the title I will do cities, average income with respect to cities, average income with respect to cities, average income with respect to cities. And you can see now it has been looking very smooth or very good. Now it was actually about the second plot, which is called the bar plot. Now let's move toward the third plot. The third is actually the pie plot. Pie plot, it is used for the categorical variables. It's not used for the numerical variables. It is used to repre, represent actually the it is used to represent the values or the ratio of a the ratio of values in a categorical variable. Categorical variable. So what does it do? Pie plot. It's a third plot here. It actually takes the data. And create the percentage of data. For example, it will tell you that San Diego have more values, Washington DC have more values, Boston have more values. It's actually work as a count plot, and we will also discuss the count plot. So what should you first of all, I want to take the calculate the value counts of a plot which you want to see. I want to see with respect to the city. It's the big column, df city dot value counts. It will be it will take you all the unique values with respect to city. It will take you to total values with respect to each city. We will store it in a values. We will store it in a values column. After that, we need to get the index of the values. So for this purpose, we will use the index, or we will use the labels. We will take the labels. These are the labels: New York, Los Angeles, and Dallas. So for this purpose, we will use that variable values dot index. After that, we will use the plt dot py, and plt dot py. After that, we will pass some two things. First of all, we will use the values, and after that, we will pass the labels is equal to labels. At the labels, we will pass the labels, and we will use the auto pct. Wait a second, I want to check the auto pct. I actually forget this value. Auto pct percentage. Wait a second, just wait a second. 0.2f percentage 0.2f. I actually forget this value sometime. Dot 0.2f, and if I ran it here, uh, percentage, but it's actually df. It's actually df. If I ran it here, then you can see it tells you about the percentage of a data. For example, I have a data. New York have 33% of a data in the data set. It acts as a count plot, and you can also use the alternative of plot, a pie plot, which is called the count plot. Let's show you count plot, how it works. How it works. Count plot. How it works. Count plot is used to represent the counts of values, the count of values in a categorical variable. Let's run it, and let's try to do the same thing with the count plot. sns dot count plot. sns dot count plot. In the count plot, what I will pass, I want to check the Dallas here. Oh, I want to check the city. So here it now it is not good. If it will be looking that it collide with each other, the values are. So for this purpose, you need to create a figure here. So I will in this way I show you. I due to this thing, I always tell you that try to make a figure. So here now it will be good. It will be pretty good. You can say New York have more data, and it will tell you the at this time the data. But in the pie plot, it will tell you the percentage of a data. There's a difference between these two things. Okay. Now we have done the four plot. Let's move forward. Make sure, if you are still here with me, make sure to subscribe my channel. Please subscribe my channel, because uh, uh, I always try to give you some quality education, some quality things which helps you in make yourself better. Now the third thing is the box plot. This fifth thing is the box plot. What is the box plot? Let's tell you. Box plot is used to remove the outliers. Remember, box plot can be used for the numerical as well as for the uh, categorical plus numerical variable. What does it mean? I will tell you in the both scenario. First of all, create a figure here. Create, and the fixed size we have 18 by 9, and here you will create sns dot box plot. And in the box plot, I will pass out the here the income or the age, where I want to check if there are any outliers in the data or not. I will pass out the age here. So here it tells you about the distribution of data. Okay, it is called the 25% of the value. Okay, 25% of the value. This is called this represent the 50. This represent. Okay, wait a second. Wait a second. Box plot. It's a 50% of value. It represent 25% of value, and this I think represent the 75% of value, or this represent the max value. This represent the max value. Let's check it. I actually sometimes forget these things, but I will also check it in the Google. So wait a second. It's the upper whisker. It's the upper quartile 4. Median Yeah, I was right. I was right. I was right. I was right. It contains the Q1 quartile. 25% of data comes in here in this. 50% of data here. 75% of data here, and the max values here. So it's actually used to remove the outliers. Anything fall below these things, fall above these things, and fall below this thing, it's considered to be the outliers. It can also be used for the two variables. Let's make it here. So at the x-axis, I want always try to put the categorical variable at x-axis. I want to put the gender here, and at y-axis I want to put the income. So if I click here, you can see these are the sum of the outlier with respect to the genders. In the income, we are getting an outliers. These things needs to be removed. And if you want to know how to remove the outliers, I have made it the data cleaning separated dedicated video for it. Try to go and watch it. Data cleaning. In the data cleaning, I showed you the way to remove the outliers. Okay. So now that was actually about the box plot. Now let's move toward the other plot, which is called the KDE plot. KDE plot, KDE plot also tells you about the distribution of data, the distribution of categorical variables, categorical variables with respect to numerical variables, with respect to numerical variables. I will tell you how it works. Numerical variables. It's actually our sixth plot, I think. It's a sixth plot. It's a sixth one. Okay, I will recommend you to do not download this video, watch it by this, because it will help me a lot. Because if you download this video, then my reach will be gone, and my channel will also be down, and I don't want this thing. Because if you help me in that way, then this thing will motivate me a lot. So let's try to create a KDE plot. So what you do, SNS, first of all, create a figure. Create a figure. We will use the fixed size as 18 by 9. Okay, we'll use the fixed size as 18 by 9. And here what will you, sns dot dot KDE plot. In the KDE plot, what we will pass, first of all, pass at x-axis a categorical variable which is called city, and at the numerical variable pass the age. Instead of income, here we will pass the age. Now let's check date time, but of none of the numeric date time is required. X variable is categorical, but one of numeric date time is required. So wait a second, is it what if I pass the income here? sns.kde plot, I have passed the income with respect to the age. I have passed the income with respect to the age. What was KDE plot? Okay. I actually forget this thing. I forget this thing how it works. Sometimes, First of all, we need to. Wait a second. I want to interrupt this thing. Okay, first of all, create a figure, and here you should. I actually forget the syntax. It's actually about a KDE plot, and in the KDE plot, you will first of all at x-axis pass the value which is called the age, any categorical, any numerical value, and after that, in the whole you will pass out any categorical value with respect to the gender. I want to check the distribution, so it will take some time maybe, because it will take some time, and we will have to wait for that time. And if it has been taking some time, then we need to restart the kernel here. Wait a second. Okay, now you can see it tells you about the distribution. So it's the male distribution and female distribution, and you can say female are quite higher than female. So it's actually tells you about the distribution of categorical variable with respect to the numerical variables. So okay, it tells you about the male, female, and tells you about the distribution. And it can also be very good when it comes to checking the distribution of any categorical variable with respect to numerical variable. So here, let's go with the 7 plot here. What is the 7 plot? The 7 plot is actually the Violin plot. It can also be used for the distribution. It can also be used for the distribution. Violin plot can also be used for the distribution. Violin plot can also be used for the distribution. It's like a box plot, but it's you can say it's look is little bit different from the box plot. It can also be used for the distribution, and here we will pass the two values. One is the categorical and other is the numerical. Fixed size 18 by 9. So SNS dot violin plot. In the violin plot, at x-axis, what should I will pass the city, and at y-axis I will pass the age. You can see it's a violin plot. It also tells you about the categorical, the distribution between two variables. One will be the categorical and another will be the numerical. Okay, so it's actually tells you about this thing. Now let's move toward the strip plot. We will also tell the strip plot. The same thing, distribution, the same thing, it is also used for the distribution. I will copy that definition here because it tells you about the different dimension of seeing the data, because there are many plots available. I will discuss here 15 plots, but the fact is you need to use it wisely just to check the distribution, and you need to be a good reader. The second thing is you need to be a good reader. So let's go with the strip plot here. And in the strip plot we will pass the same things. You can see it tells you different points. It tells you about the distribution of data. It tells you about the distribution in one dimension. It tells you about the distribution in one dimension according to the definition. You can also watch the definition. You can take you can also see the definition at net if I'm wrong, because I'm not sure about this thing. But the way I show you, that is actually the points with respect to the, it's the points of the New York with respect to the age. You can also here add some more things. If I check the with respect to the gender, then it will separate the points. You can see. Wait a second. We will wait for some time. It will maybe take some time. You can say yes. It actually also tells you about the points, and here these are the points. These are the points. Some of the male and female. It is called the strip plot. Now let's move toward the scatter plot, one of the basic plot. It's actually the scatter plot. Scatter plot. It can also be used for the distribution in. It can also be used for the distribution between two numerical variables. Numerical variables. Okay. It can be used for the. It can plot. It can be not. It is used for. Okay. So here we will also create a markdown here. So we will copy this whole thing, but just we need to change the data here. So here we will check the gender. We will take the income here. I want to check the distribution of income with respect to the age. Okay, so we will actually doing scatter plot here. I will take df new, and I will take a sample here because the data is quite long, so it has been taking time while doing the processing, and I will only get to the here 1000 rows. So for this purpose I will pass out the df new instead of df. Again I will pass out the df new, and again I will pass out df new. Now it will not take so long to do the processing here. It will be done it will be done a little bit soon as compared to the past. So that was actually from the scatter plot. Now these are things, these actually things, this is actually the income value and this is actually the age. So what if I change the age into income? Here I will take the age, and at y-axis I will take the income here. So after that, let's go what it, if I take it, then it's good. Then it's actually tells you the distribution of the points with respect to male and female, respect to gender. So that was actually from the scatter plot. Now the 10th plot, which is all about, it's about 10th plot is, we'll copy this thing, and it's a swamp plot. Swamp plot is also used for the distribution. It's also used for the distribution. Okay. Distribution, and we'll take the two values here. And the two values, and swamp plot here. Swamp plot at number 10. Okay, we have a swamp plot here. So let's try to check the swamp plot, what it can take delivered for us. I will take the same data, the new data, because it doesn't take so much time, because in the new data I have 1000 rows, and in the old data I had 2000 rows. So for the strip plot with respect, we will use here the swamp plot. Swamp plot here. Okay, let's check it. It is also same as like scatter plot. It tells you about the distribution of a data, but you can also find out the difference between the swamp plot and the scatter plot. But I think it's the same in that scenario. Swamp plot is also one of the best plot. Now there is also a second plot which is called the boxen plot. It is also used for removing the out. It is also it's look like a box plot here. So we will paste. I will paste the definition first of all here, because it's like a box plot. Is like a box plot. The box is like a box plot and can be used to show the distribution. Show the distribution. So data visualization. Okay. So it's called boxen plot. Boxen plot. Okay. We'll paste these things. We will paste the past code, because for the automacy I'll put fast code. So first of all, here I will pass only one variable, which is called the age. I want to check the distribution of age, and at the layer of swamp plot I will take the boxen plot. I will take the boxen plot here at the place of swamp plot. Let's check it. It actually tells you did it. It actually told me about the distribution. It is also used for the removing the outliers. Here is the outlier, and it's the mean, and it's the 25%. It's the 25% per. It's a mean. It's a 50% of percent. It's a 25% of percentile. It's 75%, and it's the max value, and it is the minimum value. Okay. So here we have a boxen plot here. It can also be like a box plot and can be used to show the distribution here. So till now we have covered around about 11 plots. So our video is little bit. It will be. You can say it's quite long. It's not a little bit. So let's talk about the another plot, which is called the line plot. Line plot, as I tell you, it tells you it can be used for the time series analysis. And when we create a plot of when we create a plot with respect to date, we want to check whether the things has been increasing or decreasing. So it is used for the line plot is used for the time series analysis. It is generally used for the time series analysis. Okay. Now let's run it here. So we'll copy paste this thing, box and plot. You can also check the box and plot with respect to many categories. So here we will pass, it is actually a line plot. Here we need two variables. We can age, and I want to check the age with respect to, I want to check the age with respect to the at x-axis. Okay, I want to age with respect to the income. So at x-axis we take the age, and at y-axis we take the income. So if I click here, then it tells you about the line plot. At 25 years of age, I have the income this. But since we move forward, when we are between 50 and 45, our its age is quite high, and it becomes more than lakh. So it tells you about the actually the time series analysis with respect to the time, with respect to the age, how the things goes. And that was actually from the line plot. Now after that line plot, I we will go with the relation plot here. What is the relation plot? A relation plot, it is used to find the relation between two variables. It is used to find, is used for the, for finding the relation between two variables. It is used for finding the relation between two variables. And here we will copy paste these things, just copy paste. And here we will, at the place of line plot, I want to check the rel plot. It will tell you whether one is increasing, the other increase or not. So it's actually about the relation plot. It tells you about the distribution. And we can also differentiate this thing with respect to the, we will also take the gender as whole, and to check the points and to check the distribution. It actually sometimes creates a line here which tells you that whenever the one thing increasing, the other increase or not. So if the, so it tells you about the relationship, used one relation to find the relationship between two variables. Again, we have only two plots remaining. I think we have almost covered the, it was the 10th, 11, 12 and 13. So there are only two plots remaining for us. So we will also cover these two plots, because there are many plots. But the fact is, it depends upon you which plot you can use for extracting the data. You can use a lot of plots. Here is called a heat map. Heat map, it is used to show, heat map is used to show the relationship between the variables, between the variables, between the columns, you can call it columns, or features in a color. It basically represents these things in a color, in a color intensity we can call it. Cause uh, wait a second, we will copy paste this code, we will change some things. So we create a figure here. So it was actually sns.heatmap. Here you can what should do, first of all, to find the correlation between the variables. First of all, what we will do, we will first of all do sns.heatmap. Okay, in the heat map, uh, we'll do df.correlation, and here we will take a not as true, so it will find out the relationship between multiple variables. Could not convert Dallas. Okay, for this purpose we need a numerical variables. We can't take the categorical variables. So we will first of all separate the numerical variables from categorical variables. So what should we do? We will do num variables. So df dot select d types. In the d types, we will go in the include. I want to include the int, and also I want to include the float here. So everything we did, and here we will use the num variable dot correlation. Now it will be good. Now you can see it shows you that income with income it is 1%, which means that they are 100% correlated. Income with age, it is minus 0.03. income with number, it is 0.1%, which means that if you increase the income, then it is 0.1%, it will be increase in a number. It is minus 0.034 number between age and number. Between age and age, it is 1. So it tells you about the intensity relationship between the columns or features in a color intensity. Okay, you can also take some multiple parameters here to make it a little bit more good, but here I will take some basic parameter, just because for the video will be quite long when I want to explain all these things. But for a basic point of view, but for the crash course, it's a enough thing. So in the last we have a categorical plot. So categorical plot is used to find the relationship. It is used to find the relationship or the distribution between two variables, and these will be categorical variables. Cat plot is used to find the relationship between variable between the relationship between categorical variables. Categorical variables. Okay. So what should we do? First of all, just copy paste that code. Copy paste that code. I'm just copy pasting that whole code here. Okay, I don't think so. I will use that code. Copy paste from here. First of all, run it here. Run this thing. Then copy paste it from here. Copy paste the code and just run it. Okay, we will use the cat plot here, and these both variables must be the categorical variables. So we have a categorical variable city and gender. City. Actually, use the gender more. Let's go with the illness here instead of gender. Go with the illness. So and kind is what type of plot we want to use. We want to use the count plot here. X for must be none for kind count plot. Wait a second, we don't. If I click here, yes, it tells you about the distribution between the data, but there is a problem here. The figure, if I made some sort of mistake in the figure. Okay, so let's try to go with the illness here, and at the y-axis we want to check the city. Now let's check it. Now it will tell you that in the yes Boston we have these points, at the San Diego we have these points at yes, and no points are quite high when we compare it with the yes points. So it tells you the distribution between the data, or the distribution between the two variables. Here we have some more like cat plot, pair plot. Let's explain it here. We will also use we will also use some three plots, which is called the dist plot. It is used for the univariant analysis. It is used for the these three are bonus. Univariant analysis. Univariant analysis, when we want to analyze the numerical variable. So sns.dist plot, it tells you about the distribution. So we will analyze here income. It is same like an histogram, not a histogram, but I will tell you it's quite resemblance to that. And the same thing we got the histogram, we got it here. It tells you about the distribution used for variance analysis, and tells you about the distribution. Okay, now let's move towards some more thing. Another plot, which is called the pair plot, the joint plot and the pair plot. Let's go with the pair plot. It is used for the distribution. It is used for the distribution. It is used for finding the distribution between. It is used to show the distribution, not finding. It is used to show the distribution between multiple variables, or between multiple numerical variables. Today we have covered a lot of things. Variables. Okay, so if we use sns.pairplot, just use sns.pairplot, and pass the data as pass the data what I will pass the data as new df, because new df is quite short, df new. So it will actually automatically detect and it will find out the distribution between all your. So in with the help of income, this is our distribution, with income with number, income with income, this is the distribution. So these are all the things. Okay. And at the end we will use the point joint plot. It is used to join. It is used to join. Joint plot is used for joint plot. Joint plot is used to show the distribution between two variables. It is used to show the distribution between two variables, and it's quite difficult to read joint plot. So SNS dot joint plot. Okay, joint plot at x-axis. I want at x-axis I want city or illness. DF new illness. I will take the new illness because DF new is quite short data set. It will not take so long. And at y-axis I want to check the income here. And here we will take the new data here. Let's take it. Now it shows you the distribution with respect to these two columns. So that was all from that video. Subscribe my channel, hit the bell icon, and believe me, there are many plots available, but it depends upon you how you can extract the data. Just extract the data. Overall, the ultimate goal of a data analyst or data scientist is to extract the data, is to conclude something from the data, is to extract something, is to summarize the data, is to extract something from the data. So here you can see I've explained you all these things, but there is a request for you: subscribe my channel, hit the bell icon, and like the video, because your like will give me a motivation where I will discover more and more things and I will tell you all these things. It's a crash course. More crash course will become on the pandas, data analysis, and all these things. Okay, subscribe my channel, hit the bell icon, and see you soon, inshallah.